me see. 8-6B, solving rational equations through word problems. We're going to take a look at this first one. This is not the type of word problem you're going to see. It's just helping you figure out how to set up the types of word problems you're going to see, okay? So there will be elements of this, but I'm just really showing you how to set it up for the first part. That should be a B. This question is more like the type of question you're going to see. So these first two are just helping you figure out how do we set this up? How do we get the rational expressions that we're going to get?
Wait, why should that be a B?
Because this one's A, so this one's like the next one, letter B. Oh, you're right. It's not. It's A and B and A and B. I lied. Just don't listen to me. I'm not trying to lie to you. Just not paying close enough attention is all. Okay, here we go. It says, if it takes Caden 3 hours to do a job, okay, it takes him 3 hours to do a job, what part of the job can he do in 1 hour? What fraction of the job? If it takes him 3 hours to do a job, what fraction of that job is he doing in 1 hour? 1/3 of the job, right? So in 1 hour, he's doing 1/3 of the job. So if we said in X hours, what part of the job is he doing? What would that be? X over 3, right. Okay. If it takes Andrew 4 hours to do a job, what part of the job can he do in 1 hour? 1/4. Yep. So what part of the job can he do in X hours? X over 4. Okay. That concept, that X over 4 or X over 3, is what's going to be very helpful in setting up these problems that you're going to do. Here's how it goes. It says, what if they both work on the job together? How long will it take working together? Okay, now here's how I always set these up. I kind of set it up like a chart. We have Caden and we have Andrew. Okay, we know separately what they can do. What we don't know is together what they can do. Okay, so I know that separately, Caden can do the job in 3 hours and Andrew can do the job in 4 hours. The together job, we don't know. So we're just going to call it X. Okay, we don't know how long it's going to take him. So the way we set it up is we say, well, I know Caden can do it in X thirds, and I know Andrew can do it in X fourths. So if I take those two jobs and I put them together, so basically we're saying X over 3 plus X over 4th, right? Their amount of the job that they can do, that should equal, and now here's the part you got to think about. What number do you think we set that equal to? Think maybe percentages. Maybe percents will help you think through that. What percent of the job are we trying to complete? 100% of the job. What is 100% as a number? 1, right? So you're going to say X over 3 plus X over 4 equals 1 complete job, right? 100%. Okay. So the way I always think to remember it is you're always going to say together over separate, right? Together over separate is X over 3. Together over separate is X over 4, okay? So that's how you're going to set up your fractions. And basically we're saying Caden plus Andrew equals 1 full job, right? 100% of a job done. That's going to be the challenging part of today because you guys know how to solve this setup, right? I'm just going to rewrite the problem over here. X over 3 plus X over 4 equals 1. We did this yesterday. What do you do? What? Multiply, not by 4, by 12. Multiply by your least common denominator, right? So multiply by 12 and multiply everything by 12. Don't forget to multiply that 1. So it's 12x over 3 plus 12x over 4 equals 12. Okay, and from here, just do the algebra. 12 over 3 is 4x. 12 over 4, that's 3x, equals 12. So 4x plus 3x equals 12, or 7x equals 12. So we're just going to divide by 7. And x comes out to, if you plug that in, 1.7. 1.7 what? Hours. We're talking hours here. So together, for a job that the one can do in 3 hours and the other can do in 4, together they can do it in 1.7 hours. It's a beautiful thing, right? Teamwork makes the dream work. Questions on that? Okay. I think I'm going to have you try this one on your own. Use what we did in that last one. I will read you the question just to do some clarifying, and then I want to see if you can set it up. It says a father and a daughter painted a bedroom in 6 hours. Dad said he would have taken 8 hours working alone, a painter by profession. Then Cameron wondered aloud, how long would it take me to paint the room by myself? The father reminded her that he had paid a lot of tuition to send her to Valley, and having taken Algebra 2, she should be able to work that problem out. Dad, she said, that was last year. But he encouraged her to write down the information and set up an equation. She did and had her answer in no time. Can you answer her question? So here's what I want you to think through. Here's Dad. Here's Cameron. Here's their separate. Here's their together. Can you fill in those gaps and set up the problem? You don't even necessarily need to solve the problem yet, because I want to make sure you set it up correctly first before we solve it. But see if you can set that up. It's a little different than the last one, right? But if you just follow the setup, you should be able to get there. Here we go. So separately, Dad could do it in 8 by himself. Cameron can do it in X. Together, they did it in 6, right? This is a humbling experience for this girl. How many hours did she do it in? 24 hours by herself, something that her dad does in 8, but he's a painter by profession. Painting, by the way, no joke. Takes a little work. Okay, so tell me how you set it up. Yeah, together over separate, right? 6 over 8 plus together over separate, 6 over x equals 1 complete job. Okay? I saw a lot of that, so good job. What did you multiply by? 8x. Your least common denominator is 8x. So you get 48x plus 48x, over 8 and over x equals 8x. Okay, now simplify. So you get 6x plus 48 equals 8x. Take away that 6x. So 2x equals 48, and then divide by 2. So x is 24 hours. Make sure you specify your units there. Okay. Any questions on that? All right. Last one. You want to set this one up by yourself too? This one's got 3 parts to it, 3 different printers. It says printer A, the old one, can print the payroll in 12 hours. Printer B, a better upgrade, can print the payroll in 8 hours. And printer C, the brand new one, can print the payroll in 6 hours. This one takes a little bit of thought also. It says at 9 a.m., just before the payroll was to be run on the new printer, The power went out for 3 hours. When the power came back on, the boss turned to you and asked, if we connect all 3 printers to the computer, will the payroll still be done by 3 o'clock? While the tech guys are making the connections, you quickly figure it out. How long will the payroll job take? Will it be done in time? How do you set that up? Printer A, printer B, and printer C. If we do them separately versus if we do them together, how do you set it up? What goes in the separate category here? What's A? 12 for the printer A, 8 hours for printer B, 6 hours for printer C. What's the together? That's your X. That's our unknown, right? We don't know the together right now. So if we're going to try to set this up, what's our equation going to look like? Together over separate, right? X over 12 plus together over separate plus together over separate equals what? Equals 1, a complete job, okay? Okay, so what is our least common denominator? 24. All of those are, 24 is divisible by all of those. So multiply everything by 24. So 24x over 12 plus 24x over 8 plus 24x over 6 should equal, guys, this is where I always forget to multiply by that 1. Don't do that. I always forget it. Multiply that 24 by everything, right? Okay, so simplify that. You get 2x plus 3x plus 4x equals 24. So 2 plus 3 is 5 plus 4 is 9x equals 24. Divide by 9. X is, you get 2.6 repeating, so 2 2/3 hours is what we're looking at. But we haven't answered the question yet. Will it be done in time? It started at 9. The power came on 3 hours later. So the power came on at noon. Is it going to be done by end of day at 3 p.m.?
Yes.
Yeah. If it came on at noon, it's going to be done at, what time would that be? 2 2/3 hours later.
2 hours and 40 minutes later.
2:40, right? It'd be done at 2:40 p.m. So the answer is yes. It'll be done at 2:40. You don't have to specify that, but the answer is yes. It'll be done by 2:40. 20 minutes to spare, no problem. Any questions on that? So like I said, the word problems, the hard part is just making sure you set it up correctly. But if you can remember together over separate plus together over separate plus together over separate, you're in good shape. Okay? That's the whole lesson. Right, this is going to be x plus 3 times x minus 3. So ditch this, treat it like that. Now what? What's your LCD? Your least common denominator. You have an x minus 3, you have an x plus 3, you have an x plus 3 times x minus 3. It's this, right? X plus 3 times x minus 3 can be the denominator for any of those 3 denominators that we have. So you're going to do x plus 3 times x minus 3 with all of these. But remember, don't distribute it, okay? We're going to do some getting rid of, some slashing away, if you will. So we're going to multiply by this x. It's going to look like that, over x minus 3. Then we're going to multiply here. So same numerator, x times x plus 3 times x minus 3 over x plus 3. And then that's equal to, now take the 2 times all of that, x plus 3 times x minus 3. And that's over the x plus 3 times x minus 3. Okay, when you simplify that, the x minus 3's are divisible, so that's 1, they won out. The x plus 3's will 1 out, and this one, they both 1 out. So you're looking at this plus this equal to the 2, right? At this point, now you can distribute. So x squared plus 3x plus x squared minus 3x equals 2. And then just simplify that. X squared plus x squared is 2x squared. 3x minus 3x is 0. So 2x squared equals 2. Divide by 2. So you get x squared equals 1. And then what happens when you take the square root of both sides? Plus or minus. So x equals plus or minus 1. Okay. Zoom out. Just on that problem. Any other questions? All right. That's what we got for today.